All right, in this video, we're going to spend some time graphing polar equations and building our intuition on how this works. So we are used to graphing in rectangular form. We can graph in parametric form. Now, polar form looks completely different. So this is a polar graph, and the tricky thing is it could actually be overlaid just on a normal X and Y looking graph without the circles and without the radians, and it's going to be the same graph. So it's going to be a little tricky, and we're going to work up to that. All right, so this one, if I want to know how I'm reading this represents radius 1, that's radius 2, radius 3, radius 4. So the radius, like that's 1, and then that could be 2, that could be 3, 1, 2, 3, 4. Each circle represents like 1, and it helps us graph the radius. And then these are my thetas, and this one, each little line is 1/12 of pi. So this would be 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12, which we're used to that being pi over 2. And then 7 pi over 12, 8 pi over 12, 9 pi over 12, 10, 11, 12 pi over 12, which would be 1 pi. All right, so if I want to graph the polar curve where the radius is always 2, that's just a circle around 2. So the graph of this polar curve, it doesn't matter what theta is. So if theta was 0, the radius is 2. If theta is pi over, pi over 4, the radius is 2. If the theta is pi over 2, the radius is 2. So this is simply a circle that has radius 2. All right, if theta is pi over 3, remember this is 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12 reduces to pi over 3, right? So that's the theta. Well, what's the radius that goes along with that theta? It doesn't matter. It's all radiuses. So the theta is always pi over 3. That would just be this line segment here where I've got positive radiuses. This part over here represents a theta of pi over 3 with a negative radius. So this would be the point, like this one right here. That is the point that has radius -2, but the theta is pi over 3. So I might graph it as pi over 3, radius -2. This point right here is pi over 3 theta, and the radius is 3. So the graph are just all the points that compare theta and r. All right, so let's keep building up. So if I want to graph, I'm going to graph 2 separate graphs on this one, and for some reason this isn't erasing. Great. Okay, just don't look at that random blue line there. All right, so r is equal to secant theta. R is equal to secant theta. This is kind of confusing. I'm going to use a trig identity that secant is equal to 1 over cosine, right? So from here, I'd multiply both sides by cosine, so I get r cosine of theta is equal to 1. And this tells me r cosine theta is just x, right? So x is 1. So it doesn't matter what, it just looks like the normal x is equal to 1. So if I'm looking on a normal xy plane, this is always just x is 1. So that might give me a certain theta with a radius that gives me 1. Okay, a little weird. All right, that was just a straight line. X is 1. So the next one, if I want to graph this, I'm going to say, okay, r is equal to -2 secant. We said is 1 over cosine. Multiplied by cosine. So this time r cosine of theta is equal to -2. So this graph would just be x looks like -2. So there's radius 1, radius -2, x equals -2. So the radius is different, the theta is different, but all the coordinates will end up on that line where x is -2. All right, let's do another one similar to that. So now I get r is equal to 2 cosecant theta. So I'm going to replace cosecant with 1 over sine. So multiply both sides by sine, I get r sine theta is equal to 2. R sine theta we know is equal to y, so this is just y is equal to 2. So it's just a flat horizontal line where the y is always 2. So every point on that line would have a certain theta in our number where the y would just be 2 if I kind of went through and manipulated it to look like that. So I guess probably by now you realize this is going to be equal to -3. Okay, we still haven't got into like the real good stuff. We're going to start that here. So we're not going to just try to convert this into the other form right away. We're going to graph this one, and we're going to make a t-chart with t's and thetas. Or sorry, not t's and thetas. Thetas and r's. All right, so I'm going to start with 0. Then I'll plot pi over 6. I'll plot pi over 4. I'm going to plot pi over 3 because I know my unit circle, I know these points. Pi over 2, and by then I'm going to see if I notice a pattern. All right, so if I plug in 0, the r number that correlates with that will be 2 times cosine of 0, and cosine of 0 is 1, so 1 times 2 would just be 2. So when theta is 0, so here's theta 0, the r number is 2. So I got a point, I got that dot. That's where this one starts. So for that theta, r is 2. Okay, so for the next one, I'm going to plug in theta is pi over 6. So I got to know, okay, cosine of pi over 6 is root 3 over 2. But I'm multiplying that by 2, so this is just root 3. And root 3 is about 1.7. So, okay, we said this is 1 pi over 12. This is 2 pi over 12. So 2 pi over 12... I'm going to look along this line right here, and I'm going to put a dot about 1.7 away from the origin. So that this dot right there that I just drew is where theta is pi over 6 and the radius is 1.7. All right, let's do another one. Plug in pi over 4 for cosine. Cosine of pi over 4 is root 2 over 2. But then I multiply that number by 2, so it's just root 2. Square root of 2 in the calculator is about 1.4. So 1.4. So pi over 4. Remember, this is 1, 2, 3 pi over 12, which is pi over 4. So looking along this line, I'm going to go out about 1.4. It's about right. What in the world? About right there. Let's put a little dot. Okay. Do another one. Plug in pi over 3. Cosine of pi over 3 is 1/2. 1/2 times 2 is 1. So that would be this point right there. Because the radian pi over 3 is that radian right there. But I go out from the origin 1. The radius is 1. Okay, so next one. Plug in pi over 2. Cosine of pi over 2 is 0. 0 times 2 would be 0. So at that radian, I get 0. Let's do one more. Let's do, what would the next one be? So I've done 1, 2, 3, 4, 5, 6, 7, 8 pi over 12. So what's the next one that I know? 2 pi over 3. 2 pi over 3 is going to be 8 pi over 12. So it's going to be along this line, but I got to figure out what's the x-coordinate. Okay, so 2 pi over 3, cosine of 2 pi over 3 is negative 1/2 times the 2, so I get negative 1. So that's interesting. The theta is going this way, but if my radius is negative, I go opposite, but along that same line, but in the negative direction. So this time my dot is going to be right there. So the theta is still 2 pi over 3, but then I go backwards because the radius is negative 1. Okay, so let me erase that. Okay, so let's do, okay, I said one more, let's do another one. The next one I know is 3 pi over 4. 3 pi over 4 would be this radian here. 3 pi over 4, the cosine of that is negative root 2 over 2, but I multiply it by 2 from this 2. And then I get negative root 2, which is about negative 0.4. So again, instead of going, like, if it was a positive radius, I'd go 0.4 there. But since it's negative, I go back to about 0.4. Where is it? About right. What? That looks weird. What did I do wrong? About right. Uh-oh. I'm confused. What did I do? I plugged in 3 pi over 4, got negative root 2, negative root 2. What is negative root 2? Oh, okay. It's 1.4. Negative 1.4. Negative 1.4. Okay, that's better. So along this line, negative 1.4, about right there. All right, so it's matching with that one, right? So you know this is symmetric. So at this point, I'm going to go ahead and draw this. This is just a circle. And the radius is 2. All right, so again, just kind of building some intuition on what these graphs look like. All right, let's do one more in this video, and then we'll start graphing some really weird ones. Okay, also, before I go any further, so if I wanted to graph r is equal to 3 cosine theta, it would just be a circle with radius 3. If I wanted to graph r is equal to negative 3 cosine theta, it's just going to be over here. So it'd be like a circle with radius 3 over there. R is equal to negative 5 cosine theta. It's going to be negative and then 1, 2, 3, 4, 5 radius, so something like that. All right, just some little patterns that are helpful to know, but I don't expect y'all to memorize what these look like just looking at the graph. If you want to try to do that, great, but I don't think it's going to be quite necessary. All right, so for sine theta, we're going to draw our little t-chart with thetas and r's. I'm going to start at 0. I'll do pi over 6. This one might go a little faster. Pi over 4, pi over 3, pi over 2. And then we're going to realize that we start getting some repeats. All right, so I'm going to plug in 0 for sine. Sine of 0 is 0. So 0 times 4 is just 0. So this one starts here. Okay, that's weird. Okay, plug in, so 0. So plug in pi over 6. Sine of pi over 6 is 1/2. Then I multiply it by 4, so I get 2. So pi over 6 is this radian. So along that line, I go out 2. Okay. Whoops, that looks a little ugly. All right, plug in pi over 4. Sine of pi over 4 is root 2 over 2. Root 2 over 2 times 4 would be 2 square roots of 2. 2 square roots of 2 is about 2.8. So along this radian pi over 4, I go out 2.8. There's 1, there's 2.8. All right, so far I kind of have 3 dots. Can't really tell what's going on. Okay, sine of pi over 3 is root 3 over 2 times 4 would be 2 square roots of 3. 2 square roots of 3 is about 3.4. So going along this, is it that radian? No. Yeah, so 1, 2, 3, 4 pi over 6. Sorry, 4 pi over 12 would be pi over 3. Okay, so this is the radian. And then go out about 3.4. So 1, 2, 3.4. It seems off. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. Okay. Okay, plug in pi over 2. Pi over 2 is going to be, sine of pi over 2 is 1 times 4. So pi over 2 is that radian. Go out 4, 1, 2, 3, 4. And that looks better. It looks like half a circle, right? It's going to be half a circle going above the x-axis, what we call the x-axis. And then it's going to keep going around. This one would be about right here. And it's just going to make a circle. And the radius of that circle is going to be 4. If it was, if I got the equation -4 sine theta, that would be a circle with radius 4 down here. That was real sloppy. 1, 2, 3, 4. Okay, that looks even worse. If it was 2 sine theta, that's the radius of 2. It looks right there. And the way I remember that, I just always plug in 0 to remember which one is which. If I plug in 0 and I get over here, if I plug in 0, I get here. Just start plugging in thetas and trying to figure out where that point would be. Hopefully this helped. If you have any questions, next time I see you in class, make sure you ask. And thank you for watching. Bye.